All right, so we're looking at multiplying square roots. For multiplying square roots, you have to remember two things here. The basic of this is you're going to multiply everything on the outside separate together from the inside. So keep your multiplication separate. So it's very important that you never multiply an outside number to the inside. You keep these multiplications separate. After that, look to simplify. All right, first example is root 6 times root 6. What numbers are on the inside here? 6. 6 on this one and 6 on this one. So what's the numbers on the outside though? 1. These invisible ones are there. So we're going to multiply these outside ones. 1 times 1 gives us 1. And inside of our square root, we're doing 6 times 6. 36. So we'll have the square root of 36. And what does that actually equal? 6. So what we actually did here is we squared, because when you multiply something by itself, you're squaring it. And when you square a square root, the number inside comes out with no more roots. Okay, when you square square root, it's kind of like the inverse. Okay. All right, so another example that does not have the same number inside. So root 5 times root 10. Even though the numbers are different, you could still multiply. They don't have to match in multiplication. So our inside numbers are 5 and 10. So we multiply that under one single radical. So 5 times 10. And what's that equal? 50. So inside we have 50. On the outside, those invisible ones are still just 1. We don't really need them there though. All right, so again, after we multiply, we have to look to simplify. Can we simplify 50? What perfect square fits into 50? 25. So we started with two things that were not simplifiable, and when we multiply them, we actually turn it into something we can simplify. We're going to break it down with 25 and 2. So what does this new answer become? 5 times the square root of 2. Remember, you can use your calculator, but if you just have an answer from here to there, you're not getting full credit. You have to show how you get your final answer. All right, now we see there are no more invisible ones. We'll have to take care of these numbers outside. Just stick to your rules though. So on the outside, we're going to multiply negative 11 times 3. So negative 11 times 3 is negative 33. So that'll be our new outside number. So equals negative 33. Inside we have 5 times 3. So what's 5 times 3? 15. Now look, can we simplify 15? Can we use 5 and 3? No, even though 5 times 3 is 15, we can't use it to break it down because neither 5 nor 3 are perfect squares. It has to be a perfect square. So that is your final simplified answer. All right, don't freak out. That's another way to show multiplication. Remember, parentheses mean multiplication. If it freaks you out so much, you could rewrite it, if you needed to, as root 7 times 3 root 18. Now, before we start using our rules, let's look at our radicals here. Any one of these, can we make these smaller? Can we make these numbers smaller? Or do you want to multiply 7 times 18? You could break down, someone said, 18. So if you could make the numbers smaller, it will always make the math easier. Okay? If you don't break 18 down, you would have 18 times 7. And a lot of you can't do that in your head. 126. Okay, instead, try to make the numbers smaller. So let's break down 18 with 9 and 2. So the 9 becomes a 3 on the outside that also multiplies with the other 3 out here. So 3 times 3 gives us 9 for our outside number. What's still inside is 7 times 2. What's 7 times 2? 14. And you can't break down 14 with a perfect square. Alright, so there's a couple ways you can do this problem actually. Alright, so you can multiply the outside numbers and the inside numbers first, or you can simplify it. So if you were to simplify, you would break that down with 4 times 5. And a lot of you did this. The 4 becomes a 2 on the outside and multiplies with the negative 4 already out here. So that becomes a negative 8. And a lot of you had that. And then the mistake happened in the last part. The 5 is still inside with this 5, and they're multiplying. So root 5 times root 5 is 25 inside. But the square root of 25 is 5. No more roots. When you take the square root of a perfect square, the root goes away, and you're left with negative 8 times 5, which is negative 40 for the final answer. Now, there's someone else in here that did it a little bit easier, because sometimes it's not always easier to break down the middle number or the inside numbers. Because look at what happens if you multiply right away. If you multiply right away 5 times 20, what does that make? What's 5 times 20? 100. And the square root of 100 is a nice perfect square that equals 10. And what you still have on the outside to multiply with is that negative 4. Negative 4 times 10, negative 40. All right, in the next example here, we have everything inside. So we have 15 n squared inside and 10 n to the third. So we're going to multiply 15 times 10 first. So that'd be 150. And then n squared times n to the third has now, 5 copies of n. And all of that is inside the radical still. So now we look to simplify what we have, and we could split the numbers first. So we'll split out 150, and we'll split out n to the fifth. And now we're going to simplify each of those. We're going to use 25 to break down 150, because 25 times 6. All right, so 25 now turns into a 5 on the outside. So root 6 is still on the inside. So that's our numbers simplified. And now let's look at n to the fifth. That's an odd power, so we're going to bring it down to the previous even, to the fourth, and we'll leave 1 copy of n inside. So the square root of n to the fourth is now n squared on the outside. And so now everything together on the outside will be 5n squared. So 5n squared. And still inside is 6 and n. So root 6n. Alright, so here's another problem where we're multiplying. We're taking root 2 and we're multiplying to 2 things inside here. So we are going to distribute and remember our rules. So root 2 times root 2, well, they're both inside. So we're going to multiply those together inside to be the square root of 4 on the first distribution. On our next distribution, root 2 times 3 root 6. So we'll do 2 times 6 inside. 2 times 6 is 12. So we'll have 12 inside the radical. On the outside, we take the 1 that's here and multiply with the 3. That is a 3 still. All right, so we still have more simplifying to do. So root 4 is actually equal to 2. And now we have plus 3 root 12. So hopefully you remember root 12 can be broken down with a perfect square of 4 times 3. So root 12 will turn into a 2 that comes out that multiplies with the 3 already out here. 2 times 3 will give us 6. So 3 root 12 will turn into 6 root 3. And don't forget, we still have that 2 that came out over there. So 2 plus 6 root 3. Don't combine these two. They're not like terms. The 2 does not have a radical. So that's our final answer on this example. All right, one last example. I'm not sure if I said the last one was the last one, but this is the last one. We can see multiplication as powers. So when we have a power outside, don't forget, so we're going to take the outside power and shower all the inside powers. So the 3 gets it, not so bad, but then the root 5 gets it as well. So we'll have 3 to the power of 2 and the square root of 5 raised to the power of 2. Well, 3 squared is 9. But when we square a square root, what happens is it gets rid of it. And what comes out is just the 5. And now 9 times 5 would give us 45 for that answer. Now, another way to think about it is there's 2 copies of the inside part here. So if we write it another way, we can see this happening. 3 root 5 times 3 root 5. So we can see the 9 right there. And then the root 5 times root 5 is 25, but we know that's going to be a 5 on the outside. And there's that 5 right there. All right, may the math be with you.